The world was silent, not peaceful, tense, nervous, waiting. The Soviets had already sent humans into space. America was behind. Fear ran through every corridor of power. Pride demanded action. The moon became the stage for a global showdown. President Kennedy spoke, and the nation listened. We choose to go to the moon, not because it is easy, because it is hard. Rockets would fail. Lives were at risk. But step by step, bolt by bolt, heartbeat by heartbeat, humanity was about to take its first step on another world. And this was only the beginning.
Why America decided to go to the moon, the beginning of the space race. The night was cold. Not outside, not the wind. But inside Washington, D.C., a different kind of heat simmered, quiet, invisible, almost suffocating. People didn't know exactly what was happening yet. But at the heart of power, inside those thick white walls, an invisible race had begun. It wasn't a war, not in the traditional sense. No bullets, no bombs, yet the feeling, it was exactly like one. Tension stretched across the room, across the nation, across the world. They called it the Cold War, a war without fire, without smoke, only fear and uncertainty. And the looming question of dominance. In those days, America asked itself one terrifying question. If the Soviets reach space first, who will control the Earth below? It was not just a thought. It was a sleepless dread. The first shock, Sputnik 1, October 4th, 1957, a tiny metal ball just 23 inches across, weighing only 184 pounds. But when it soared into the sky, the United States froze. Sputnik 1, the world's first artificial satellite, a tiny dot in the blackness, sending out beep, beep, beep signals into the empty sky, circling the Earth, relentless, precise, unforgiving. Every radio on the planet caught the signal, and for America, the sound was like a slap across the face. No one panicked in the streets, but the government, oh, they felt it, deep in their bones. If the Soviets could launch a simple metal ball into orbit, then a missile could follow, and the missile could carry destruction, falling from space in a matter of minutes. The thought alone, it gripped the nation. It pressed down on their chests, and it refused to leave. Then came the next shock, like it wasn't even a month later. A dog, a living, breathing creature. Laika, the Soviets sent her into orbit in Sputnik 2. Alive, alone, floating above the Earth. It was the first living being in space, not a human yet, but humanity still watched, paralyzed. Soviet scientists were calm. Their faces revealed pride, confidence. Every gesture deliberate, quiet, unshakable. Meanwhile, across the Atlantic, American engineers sat in silence. Staring at schematics, staring at their hands, at their feet, helpless. It wasn't just jealousy, it was fear. A creeping, gnawing fear. They were behind, by months, maybe years. And the world was watching. America's growing fear. America realized something crucial. This wasn't about space. This was about power. Who dominated the skies, dominated the Earth. Every report from Moscow, every grainy photo of Laika floating in orbit, every broadcast from Radio Moscow, echoed in the minds of American leaders. We cannot afford to fall behind. The fear was quiet but unstoppable. It slipped into every meeting, every newspaper headline, every conversation on the streets. They're above us, watching, waiting, planning, and the people, ordinary citizens, felt it too. The headlines screamed, Soviet satellite orbits, American HOMES, are we safe? Who controls the sky? Mothers held their children closer at night. Fathers stayed awake by the radio. Everyone wondered, if they can do this, what next? Pressure mounts in the government. Inside the White House, the lights burned late. Senators slammed papers onto tables. Generals shouted. Scientists ripped their hair out. The country was tense. Every decision carried weight. Every delay felt like disaster. And amidst all this chaos, one thought became clear. We must act. And we must act fast. Yuri Gagarin changes everything. Then came April 1961. A quiet morning shattered by news that swept the nation like a hurricane. Yuri Gagarin, the first human being in space. The Soviets did it, and the world had to watch. The image of Gagarin, smiling from orbit, his tiny spacecraft circling Earth, etched itself into the minds of Americans everywhere. President John F. Kennedy sat in silence as the news was delivered. No words, no gestures, just eyes narrowing, fingers tapping the desk. Because for the first time, the possibility was real. The Soviets were ahead. And humanity was watching. A nation in crisis. The press had a field day. Every headline screamed urgency. U.S. losing space race. Soviets lead humanity. Can America catch up? Inside the corridors of NASA, chaos ruled. Engineers argued over rocket designs. Technicians stayed late, checking and rechecking every bolt, every diagram, every calculation. Nothing could be rushed, yet everything felt urgent. Kennedy's moment of decision. Kennedy knew the nation needed a vision, a plan, a goal that would focus every mind, every dollar, every ounce of effort. And then in a speech that would echo through time, he said, "We choose to go to the moon, not because it is easy, but because it is hard. Because that goal will serve to organize and measure the best of our energies and skills." Pause. The weight of his words sank, every syllable deliberate, heavy, slow. Because he knew this was more than science, it was politics, it was fear, it was pride, it was survival. The birth of NASA, the political pressure was immense. The Cold War demanded action. The public demanded leadership, and so NASA was strengthened, budgets approved, rockets designed, engineers and scientists mobilized. The nation moved slowly, painfully, methodically. Every failure documented, every test recorded. The early rockets exploded on test pads, engines failed, modules crumpled, lives were at risk, time was slipping, but America learned to persist. Step by step, bolt by bolt, calculation by calculation, every setback a lesson, every small victory a reason to continue. A human perspective. It wasn't just politics, it wasn't just Cold War strategy. It was men and women tired, frustrated, sometimes hopeless, building a dream that felt impossible. They argued, they cried, they laughed at absurd problems that would break lesser minds. Some doubted. Some lost hope entirely, but slowly, inexorably, they pushed forward. And in the process, the world watched, waited, and wondered, could America really catch up? Could they reach the moon before the Soviets? Could humanity take its first giant leap into space? The weeks that followed Yuri Gagarin's flight were tense. Every newspaper headline, every evening broadcast hammered the same truth. America was behind, and it was no longer theoretical. It was real, cold, immediate. Inside NASA offices, the smell of ink and metal hung heavy. Engineers hunched over blueprints. Every pencil stroke mattered. Every calculation could mean success or disaster. Some mornings, the staff would walk into the launch hangars, shoulders slumped, coffee in hand, trying to mask the exhaustion. Yet beneath the fatigue, a spark of determination burned. They had no choice. The world was watching. Political pressure mounts. President Kennedy faced mounting pressure in Congress. Some questioned the cost, billions of dollars, taxpayers' money, poured into a dream that might fail spectacularly. Others questioned the timing. Why aim for the moon now? Why not Earth orbit first? Kennedy's answer was simple, not easy, simple. He knew the symbolic weight of space. The moon was more than rock. It was the ultimate stage for global influence. Whoever planted their flag, their first would claim not just territory, but prestige, ideology, and the psychological upper hand in the Cold War. America's fear deepens. Every failure by the Soviets now felt like a shadow creeping over American streets. Children would ask at school, will they come down from space and take over? Mothers whispered to their children, the sky isn't safe. Men discussed quietly at diners and bars. They've got rockets we don't understand. How far ahead are they? Fear was no longer abstract, it was human, tangible. It affected daily life, sleep, meals, conversations. America was under invisible pressure from above. Planning the impossible, NASA's engineers were suddenly tasked with something unprecedented. Not just rockets to orbit Earth, not just sending satellites. They needed humans to survive in space and land on the moon. And not just survive, they needed to come back alive and do it before the Soviets. Every test was scrutinized. Every piece of metal measured, every bolt, every circuit, every switch, a possible difference between triumph and tragedy. Meetings lasted hours, arguments flared. Some engineers shouted over small mistakes, while others quietly withdrew, unsure if their calculations could ever be enough. Yet slowly, methodically, they made progress, not dramatic leaps. Not Hollywood-style triumphs, just slow, human, painstaking progress. The public needs a dream. Kennedy understood something many politicians did not. The moon mission had to capture the imagination of the people. It wasn't enough for rockets to exist. Americans needed to believe, to feel the moon as a goal worth sacrificing everything for. He gave speeches, slow, deliberate, heavy pauses, each word chosen like a delicate piece of machinery. We choose to go to the moon. We choose to go to the moon in this decade, not because it is easy, but because it is hard. The nation listened. Some scoffed, some cried, but slowly belief spread. Children drew rockets in school books. Newspapers ran diagrams of modules, engines, and capsules. Families imagined walking on lunar dust, flag in hand. Human stories behind the mission, behind the headlines, real people worked silently. Margaret, a mathematician in the control room, spent nights calculating orbital trajectories by hand. Her eyes burned, her fingers cramped, yet she whispered to herself, "If I miscalculate, someone dies. If I calculate right, history changes." John, a test pilot, repeated simulations until his hands were raw, sweat dripping from his brow, muttering numbers under his breath. Some days he doubted. Some nights he feared he'd never make it home, and still, step by step, they pushed forward, every failure a lesson, every minor success a small victory. The moon becomes a political weapon. Every international broadcast carried the same message: who controls space controls the future, and the Soviets had the early advantage. America couldn't afford to wait. Every decision in Congress, every dollar allocated was influenced by fear, pride, and ambition. The moon was no longer a place, it was a symbol of supremacy. And NASA, it became the instrument of that symbol, a slow-moving, incredibly complex machine of human effort and political pressure. Challenges and failures. The journey to the moon was never straightforward. Rockets exploded on the launch pads, engines caught fire, capsules failed. Astronauts trained for hours in simulators, only to have systems fail over and over. Every test brought frustration, exhaustion, and anxiety, yet human determination refused to break. Engineer in a late-night meeting, "We've tried everything and it still fails." Senior scientist, "Then we try again, one more calculation, one more test, step by step." That became the mantra. Step by step, slow, human, imperfect. The tension builds. By the end of 1961, the pieces were in place. Satellites, capsules, rockets, scientists, engineers, astronauts. The nation watched and waited. The tension was palpable. Every headline read like a drumbeat, every broadcast like a countdown. Every ordinary American felt it, an unspoken question hanging in the air: can we do it? Can we really reach the moon? A dream takes shape, and so the moon ceased to be just a celestial body. It became a goal, a challenge, a test of skill, courage, and perseverance. Every engineer, every mathematician, every astronaut felt the weight of history on their shoulders. Some nights they lay awake, counting stars, imagining the moon, silent, barren, waiting. A goal that seemed impossibly distant, yet achievable step by step.
The story of America's first astronauts didn't start with cheers. It started with fear, and paperwork, and rockets that refused to obey gravity. Project Mercury was America's first attempt to send a human beyond Earth. Simple in theory, impossible in practice. Everyone in NASA knew it. The astronauts were chosen, not randomly, not because they were brave, but because they were the best of the best. Pilots, engineers, people who could stay calm while death hovered behind every switch. Each of them went through training that was exhausting, painfully detailed, slow, boring to anyone who wasn't there. They learned how to float in water tanks that simulated weightlessness. Weeks. Sometimes they fell asleep in the tanks, or felt their muscles cramp, or thought quietly, "I might die here." The simulators were machines of cruelty, rockets that might fail, controls that might lock up, alarms that screamed like banshees in the dead of night, and all of it was meant to prepare them for what could happen in space, though nobody could truly know. Training every detail. Mercury astronauts memorized every inch of their spacecraft. Panels, switches, levers, all of it. They practiced emergency egress. What to do if the capsule spun out of control? If oxygen ran out? If the heat shield failed on re-entry? Every procedure was repeated until muscle memory was perfect. But perfect didn't guarantee safety. Not by a long shot. Some astronauts joked to keep their nerves in check. Some cursed under their breath. Some stared silently at the ceiling, imagining the stars. Earth shrinking below them. Rockets that failed. Meanwhile, the rockets themselves seemed determined to sabotage humanity. Engines exploded on test stands. Capsules tumbled uncontrollably. Telemetry sent garbled data. Every failure cost time. Every failure cost money. And sometimes every failure cost hope. Scientists would gather in the early morning, rubbing sleep from their eyes, staring at the smoking wreckage, whispering, "We can't send a man in that. Not yet. Not ever." But they tried again. And again. Because the alternative, doing nothing, was unthinkable. The first Mercury flights. By 1961, the first flights were finally ready. Alan Shepard became the first American in space. A brief suborbital flight. It lasted mere minutes. But for the nation, it was monumental. A small step for man, a small victory for America, but a slow, methodical one. Astronauts felt both elated and terrified. Shepard reported back from space, his voice calm, deliberate, almost boring, if you didn't know what he had been through. Flight is nominal. Systems performing as expected. Those words, simple as they were, carried the weight of a nation. Every test, every failure, every hour of boredom in training had led to this. Slow progression. The Mercury program was intentionally slow. NASA didn't rush. Even the slightest mistake could be fatal.
Orbit. Every report, every check of the spacecraft systems took hours, sometimes days, to analyze. Engineers would debate endlessly over minor anomalies. Some might call it overcautious. Some might call it maddening. But it was necessary. Because space didn't forgive mistakes. Space was indifferent. And Mercury astronauts had to survive it. Enter Gemini, doubling the stakes. Once Mercury had shown that humans could survive in space, NASA moved on. Gemini. The name itself suggested pairing, duality, because now astronauts would not just orbit. They would dock with other spacecraft. They would perform extravehicular activity, spacewalks. Gemini missions were far more complex. More risk, more procedures, more failure waiting in every corner. Docking two spacecraft in orbit? Imagine threading a needle while floating at thousands of miles per hour. Slightest error could send both vehicles spinning uncontrollably into the void. Astronauts trained for months in simulators. Sometimes two would sit side by side, running through procedures repeatedly. Step 1, check thrusters. Step 2, align the spacecraft. Step 3, approach slowly. Over and over, until it became second nature, or as close as it could get. Spacewalks, EVA. Extravehicular activity was another nightmare. Buzz Aldrin, Jim Lovell, and their colleagues practiced endlessly. They learned how to exit the capsule, tether themselves, move slowly in zero gravity, every motion rehearsed, every tool accounted for. It was exhausting. Emotionally. Some astronauts felt claustrophobic. Some felt panic when tether lines tangled. Some imagined floating away silently into darkness. And yet they kept going. Because failure was not an option, because America needed to demonstrate capability, and because the moon awaited, far above, silent and patient. Technology evolution, slow sleep-inducing, human. Every system, every module, every control panel evolved painfully slowly. Engineers argued over material choices, over insulation, over the tiniest sensor. Sometimes weeks were spent deciding whether a switch should be red or white. And yes, this is the kind of detail that would bore anyone who wasn't living it. But in the hands of humans, real, exhausted, frustrated humans, it mattered. The evolution of technology wasn't glamorous. It wasn't cinematic. It was painstaking, slow, methodical. Real. And humans. They were imperfect. They misread data. They miscommunicated. They forgot minor steps. They panicked in simulations. Yet step by step, mission by mission, they improved, learning from failure, adjusting, improving, slowly, painfully, beautifully, human. This was the essence of Mercury and Gemini, not triumph, not glory, but slow, steady, relentless human progress. By the middle of the Gemini program, NASA had settled into a rhythm, slow, methodical, exhausting. Every mission was carefully planned, every contingency considered, and yet uncertainty hung like a shadow over every decision. Gemini wasn't Mercury. It demanded more. More precision, more courage, more patience. The astronauts were no longer just passengers. They were operators, engineers, test pilots, survival experts. Higher than ever. Period. Docking in orbit. Docking was a nightmare. Picture this. Two spacecraft, orbiting the Earth at thousands of miles per hour. No friction. No brakes. Just a tiny gap between success and disaster. Astronauts practiced endlessly. Approach, approach, slow. The words repeated in simulators until they became mantra.
Controllers on Earth sweated over every telemetry reading. Every thruster adjustment had to be perfect. Even a centimeter off, and both vehicles could drift away, spinning helplessly into the void. The first attempts were messy. Some approaches failed. Some docking mechanisms jammed. Astronauts cursed, laughed nervously, and tried again. It was exhausting, boring in the sense that it demanded repetitive precision, and yet the tension was unbearable. One mistake, one miscalculation, could be fatal. The first spacewalk's extravehicular activity, EVA, added another layer of complexity. Astronauts had to exit the safety of the capsule, tethered only by a lifeline, floating in the void. Deliberate. Slow. Calculated. A small misstep could send them spinning into darkness. Buzz Aldrin, Gene Cernan, Jim Lovell, all trained in simulators, in giant water tanks, over and over. Hours passed like days. Muscles ached. Confidence wavered. And yet, they practiced. Because the moon wasn't forgiving. And the Gemini program was building the foundation for Apollo. Technical details that took weeks. NASA's engineers spent weeks, sometimes months, analyzing simple anomalies. A tiny misalignment in a thruster, a sensor that blinked irregularly, a hatch that didn't latch perfectly. Every anomaly was a potential disaster. Every correction required human ingenuity, debate, and exhaustion. Some days, engineers stayed in the labs until sunrise. Some nights, arguments flared, voices echoing off metal walls. Sometimes mistakes were caught too late. A failed test meant rewriting procedures, recalculating trajectories, rethinking steps. It was boring, yes. But that slow, painstaking attention to detail was the backbone of survival. Human stories behind Gemini. The Gemini astronauts were human. Wally Schirra joked endlessly during training. "Maybe I'll float away tomorrow," he said, laughing, though his hands shook slightly. Gus Grissom stared at the simulators silently. He replayed every emergency scenario in his mind, trying to memorize every failure, every possible contingency. Some astronauts whispered to themselves in the dark, imagining the worst-case scenarios. Others wrote letters to loved ones, unsure if they'd ever deliver them. NASA's human layer, the astronauts, was as important as any rocket. Because machines can fail. But humans? Humans adapt. Humans endure. Learning from failure. Not every Gemini mission was perfect. Thrusters misfired. Dockings failed. Spacewalks were awkward and terrifying. Every mistake taught a lesson. Every failure informed the next mission. Every tiny adjustment became part of a growing library of knowledge. It was frustrating. And sometimes, it was painfully boring to the public watching from Earth. But to NASA, every failure was a step forward. Every error a teacher. Every success a glimmer of hope. The psychological strain. Life in orbit was lonely. Hours stretched endlessly. Communication with Earth was delayed. Every movement had to be deliberate. Every action planned. Astronauts battled claustrophobia, fatigue, and the constant knowledge that a single misstep could be fatal. Some hallucinated slightly during long orbits. Some argued over trivial things. Some cried quietly unseen, overwhelmed by the enormity of what they were doing. Training on Earth had prepared them technically. It hadn't prepared them emotionally. Yet step by step, they endured. Gemini's major milestones. Despite the slow pace, milestones were achieved. Possible. Spacewalks, initially terrifying, became controlled, if still exhausting, operations. Long-duration missions taught NASA how the human body responded to weightlessness. Communication protocols improved. Rockets became more reliable. Every minor achievement built confidence. Every successful EVA or docking operation was proof. Humans could survive, operate, and function in space. And yet, there was always more to do. The moon was still distant. Apollo was still ahead. The slow, sleep-inducing evolution. NASA's technology evolved like a glacier. Relentlessly. New capsules replaced older ones. Thrusters improved. Navigation systems grew more sophisticated. Each system added complexity. Each improvement required training, testing, recalibration. And all of it felt painfully slow to outsiders. People wanted spectacle. NASA delivered methodical, deliberate progress instead. boring in appearance, crucial in reality. Lessons learned. The Mercury and Gemini programs taught NASA three essential lessons. Humans can survive in space, but only with meticulous preparation. Complex operations like docking and EVA are possible, but require repetition and patience. Slow, painstaking attention to detail is the key to success. More than bravery, more than speed, more than technology alone. The programs shaped astronauts, engineers, and the nation. America now understood the scale of the challenge. The moon was no longer a distant dream. It was a goal within reach.
Human imperfection and triumph. Humans remained imperfect. Mistakes happened.
Arguments flared. Anxiety and fear lingered. Yet, in the process, humans adapted, learned, persisted. Step by slow step, mission by mission, they grew closer to the moon. Mercury and Gemini were not glamorous, dramatic. They were human. And it was exactly this humanity, flawed, determined, relentless, that laid the foundation for Apollo. The Apollo program began not with a grand vision, but with chaos. Meetings stacked on meetings.
Engineers pacing endlessly. Budgets shredded and argued over. Every decision a negotiation between pride, fear,
and politics. NASA had learned from Mercury and Gemini. Slow progress, painstaking repetition. But Apollo was going to the moon. And suddenly, slow progress wasn't enough. The first problem was simple: scale. Rockets that had carried one man now needed to carry three. Capsules that had orbited Earth now had to survive lunar landing. Every system had to be bigger, stronger, more reliable. And yet, nothing in human history had prepared anyone for this. Meetings and arguments. Engineers gathered daily, sometimes twice a day. Often they argued for hours over tiny decisions. Which alloy for the heat shield? How to route electrical cables. In the service module? Should the oxygen tank be 10 centimeters longer or shorter? Budget officers were relentless. They questioned every dollar, every rivet, every bolt. Do we really need 2 backup pumps for the system? Engineer, yes. If one fails, the mission fails. It's that simple. These arguments could go on for hours. Tempers flared, coffee cups spilled. Some engineers slammed doors. Some simply sat in silence, exhausted, replaying every calculation in their heads. Every tiny detail mattered, because one error in a multi-ton rocket could mean catastrophe. Saturn V, the giant. Then came the Saturn V, the largest rocket ever built, 230 feet tall, 6.2 million pounds fully fueled. Every stage designed to perfection, or near enough. Engineers obsessed over its engines. F1 engines, 5 in the first stage, each producing 1.5 million pounds of thrust. Every nozzle, every valve, every igniter scrutinized endlessly. Test after test, the engines failed. Sometimes they exploded, sometimes they barely fired. Telemetry data confused even the most experienced engineers. Engineer in frustration, we tested it again. Why is it failing now? Colleague, because it's a rocket, and rockets are terrible creatures. Failures were frequent. Sometimes public, sometimes behind closed doors. But each failure taught a lesson. Each lesson brought Saturn V closer to reliability. Apollo planning. Apollo planning was an exercise in patience. Every mission had layers of complexity. Launch procedures, lunar orbit insertion, lunar landing sequence, re-entry trajectory. Every variable was modeled. Every scenario simulated. Weeks were spent calculating fuel consumption. Weeks more on trajectory adjustments. Engineers ran simulations over and over. And even then, the unknowns of space ensured nothing was guaranteed. The astronauts trained endlessly. Weightless simulations, lunar module mock-ups, emergency egress drills. Every tiny movement choreographed, considered. It was slow, it was boring, but absolutely necessary. Apollo 1 fire. Then, tragedy struck. Apollo 1, scheduled for a routine test, became a nightmare. A cabin fire. 3 astronauts, Gus Grissom, Ed White, Roger Chaffee, lost their lives. The nation reeled. NASA froze. Every engineer, every scientist, every administrator questioned themselves. Investigations dragged on. Every wire, every material, every valve inspected. What caused the fire? How could it have been prevented? Multiple small failures, human errors, and mechanical oversights converged into catastrophe. A horrifying reminder, space was merciless. And slow, methodical preparation was not just a habit, it was survival. Restarting Apollo. After Apollo 1, the project was nearly cancelled. Budgets tightened, public scrutiny intensified, but NASA persisted. Engineers went back to the drawing boards. Every mechanical system reevaluated, every material reconsidered, every procedure rewritten. Training resumed. Astronauts returned to simulators. New safety measures implemented. Every bolt checked twice. The program restarted, slowly, painstakingly, and with a renewed respect for human fragility and machine unpredictability. Mechanical details that matter. Saturn V's stages were redesigned. Fuel lines rerouted. Oxygen tanks reinforced. Igniters adjusted. Systems recalibrated. Engineers debated torque settings on bolts. They measured vibrations in test stands. They analyzed acoustic frequencies that could interfere with instruments. Some of it felt unnecessary. Some of it felt boring. But it all mattered. Apollo demanded perfection in imperfection, because the moon did not forgive mistakes. Human stories in Apollo. Despite the machines, humans were at the heart of it all. Test engineers slept in labs. Astronauts rehearsed procedures endlessly. Technicians rechecked valves and sensors multiple times. Some nights were quiet, contemplative. Others filled with shouting, coffee spills, and furious scribbles on chalkboards. Humans remained imperfect. Fatigue and fear were constants. Yet progress was made. Step by slow step. Bolt by meticulous bolt. Heartbeat by heartbeat. Testing and failure brought anxiety. Rockets exploded on the pads. Engines misfired. Instrumentation failed. Capsules leaked oxygen. Engineers cursed. Engineers celebrated minor successes. The schedule was relentless. Public pressure mounted. Political pressure mounted. And yet the work continued. Because success depended on relentless attention to detail. The months after the Apollo 1 tragedy were painstaking. Every engineer, every technician, every astronaut moved carefully. Fear lingered in the air, like smoke that refused to leave the room. Saturn V's engines underwent redesign after redesign. Every fuel line rerouted. Every valve recalibrated. Every igniter scrutinized under magnifying glasses and high-speed cameras. Test failures continued. Engines sometimes roared too violently, shaking the test stands. Sometimes they barely fired at all. Each failure forced months of analysis, simulations, and painstaking rework. NASA's meetings became marathon sessions. Engineers argue over tolerances, welds, and metal fatigue. Budget officers countered, insisting on compromises. Political overseers demanded faster timelines. Every decision was a negotiation. Every minor disagreement could delay the program for weeks. Safety first, boring second. The crew modules were redesigned with obsessive care. Heat shields were layered and tested. Oxygen tanks placed to reduce fire risk. Escape hatches redesigned for rapid egress. Every screw, nut, and bolt measured. Some engineers obsessed over small things no outsider could notice. How vibrations affected wiring insulation, how temperature changes expanded or contracted tiny components, how acoustic noise could interfere with communication systems. Hours were spent repeating tests that, to outsiders, seemed boring. But NASA understood the stakes. They were sending humans into the void, far from rescue. Boredom and preparation could save lives in execution. Training the astronauts again. Meanwhile, astronauts returned to simulators. Buzz Aldrin, Michael Collins, Neil Armstrong, and their colleagues ran endless scenarios. Lunar module approaches, docking sequences, manual landings, emergency egress drills. They slept in mock capsules, sometimes waking in the middle of the night to run procedures again, sometimes panicking silently at the thought of failure. Each movement became rote, each emergency scenario memorized, each action slow, deliberate, repeated. This was training that few humans had ever endured, and it was necessary for survival. The complexity of Saturn V. Saturn V's sheer size was intimidating. 3 stages. F1 engines producing 1.5 million pounds of thrust each. Thousands of valves, circuits, and pumps all needing to work in perfect sequence. Test firing was terrifying. Engines roared with vibrations that could shake buildings. Sometimes the sound waves themselves damaged equipment. Engineers monitored every gauge, every sensor, every microsecond of data. Failures often meant redesigns, delaying missions for months. Yet each failure taught lessons. Each small victory, an engine firing correctly, a stage separation successful, was celebrated quietly among those who understood the stakes. Apollo 7 and the first real steps. Apollo 7 marked the first manned flight after Apollo 1. It was carefully orchestrated. The crew orbited Earth for 11 days. Systems tested, procedures verified, confidence rebuilt. Every orbit was slow, deliberate, documented in excruciating detail. Nothing left to chance. The world watched with bated breath, largely unaware of the technical tedium behind each successful maneuver. NASA had learned its lessons. Patience was now as vital as courage. Mechanical details, boring but crucial. The lunar module's descent engine was analyzed endlessly. Fuel mixtures calculated to exact tolerances. Thrusters tested under multiple orientations. Landing gear stress tested with weights simulating the astronauts and equipment. Guidance systems reprogrammed again and again. Every switch labeled. Every wire routed. It was mechanical perfection married to human imperfection. And this painstaking detail, boring as it seemed, was the key to survival. Apollo 8, orbiting the moon. Apollo 8 marked a turning point. The first humans to leave Earth orbit and travel to lunar orbit. The journey took 3 days, slow and tense. Every calculation verified, every system monitored. That had never been done before. Lunar orbit insertion, mid-course corrections, communication with Earth across hundreds of thousands of miles. Every minor anomaly was analyzed. Even the tiniest blip on a sensor could trigger hours of discussion back on Earth. The human element remained critical. Astronauts adapted, reacted, and persevered. Slowly, carefully. With sweat and fear mingling with excitement. Apollo 9 and 10, perfecting docking and lunar module operation. Before the moon landing, Apollo 9 and 10 were rehearsal missions. Apollo 9, Earth orbit docking practice with the lunar module. Spacewalks, life support tests. Apollo 10, full lunar module separation and approach in lunar orbit. Simulated landing maneuvers, coming terrifyingly close to the moon's surface. Engineers and astronauts repeated every movement over and over. Hours of slow testing, minutes of tension. Everything documented, analyzed, and rechecked. The process was boring in narration, but the suspense in reality was palpable. Apollo 11, final preparations. Apollo 11 demanded perfection. Neil Armstrong, Buzz Aldrin, Michael Collins, every detail rehearsed. Saturn V fueled and tested repeatedly. Lunar module checked bolt by bolt. Thrusters, fuel lines, oxygen valves, all meticulously inspected. Engineers stayed awake nights, reviewing diagrams, recalculating margins. Astronauts ran simulators endlessly, every contingency drilled, every emergency scenario memorized. Failure was unacceptable. Success required slow, patient, painstaking preparation. Human and machine together. Apollo was not just a machine. It was humans operating with humans inside machines in a silent void. Every failure of hardware was a test of human perseverance. Every human hesitation tested the machinery. The program was exhausting, slow, painful, boring, but it was real. It was survival. It was the moon. The morning of July 16, 1969, was quiet. Not silent, not empty, but heavy with anticipation. Every sound, every movement, every heartbeat seemed amplified. Launch preparations were meticulous. Engineers walked slowly along the Saturn V rocket, checking panels, valves, and connections. Astronauts moved in measured steps, double-checking their suits, their helmets, their harnesses. Inside mission control, technicians stared at screens, tapped keyboards, scribbled notes. No one rushed, not because there was time, because there could be no mistakes. Countdown. Painfully slow. T-minus 10 hours, 9 hours. Every minute analyzed, every procedure double-checked. Engines loaded with fuel. Pressures monitored. Electrical systems tested. Telemetry checked. Redundant systems verified. Each call from the tower sounded deliberate. T-minus 4 hours, 30 minutes. All systems nominal. T-minus 3 hours, 15 minutes. Weather acceptable. And between each call, silence. A quiet tension that filled the room. A waiting that felt like hours. Because even seconds mattered. Spacecraft modules. Apollo 11 consisted of 3 modules. Command Module Columbia, the living and control space for the astronauts. Service Module, housing engines, fuel, and life support systems. Lunar Module Eagle, designed for landing and ascent from the moon. Astronauts climbed carefully into the command module. Harnesses strapped, communication helmets sealed. Technicians checked and rechecked the interfaces between modules. Every bolt, switch, and circuit accounted for. Engineers whispered to each other, explaining small details to those listening. The modules had to function perfectly, and yet no one could predict how the human body would respond to the journey ahead. Liftoff. Finally, T-minus 0. Ignited in a controlled eruption. The engines roared. The flame and smoke billowed around the launch pad. The vibration traveled through every bone. The rocket lifted slowly at first, then faster, then disappeared into the sky, trailing smoke, fire, and sound. Astronauts felt every shift, every vibration, every tiny adjustment of the rocket's trajectory. Mission Control monitored readings obsessively. Telemetry streamed data continuously. Each stage separation was slow, deliberate, perfectly timed. The world watched in awe, but inside the spacecraft, every moment was a calculation. Step by step, bolt by bolt, minute by minute. Translunar injection. After Earth orbit insertion, Apollo 11 prepared for the translunar injection. The command module and service module aligned carefully. The lunar module checked and locked in place. Engineers calculated burn times to fractions of a second. Fuel levels checked repeatedly. Trajectory simulations rerun on computers. The burn began. Engines fired. Velocity increased gradually. The moon's gravity, distant yet influential, began tugging. Astronauts monitored every dial. Communications from Mission Control flowed slowly. Houston, all systems go. Columbia, adjust attitude 0.3 degrees starboard. Even minor corrections could mean thousands of miles difference. Deep space silence. Once Apollo 11 left Earth orbit, space felt quiet. Silence inside the spacecraft, punctuated by slow, deliberate radio communications. Astronauts moved methodically, meals taken carefully, systems checked hour after hour. Sleep cycles were scheduled, but interrupted by tasks and minor anomalies. The world below seemed distant, abstract, and yet every action had purpose. Even boredom became a survival. Long hours of monitoring instruments and recording data demanded patience. Slow patience. Approach to the moon. As Apollo 11 neared lunar orbit, engineers recalculated trajectories again. Lunar orbit insertion burn was scheduled precisely. Command Module Columbia separated slightly from the service module for alignment checks. Every thruster tested. Every sensor monitored. Astronauts noted minor anomalies but reported calmly. All systems nominal. The moon loomed slowly, growing larger in their viewports. Gray, silent, immense. They approached with extreme caution. Mission Control echoed instructions slowly, deliberately, with pauses between each word. Apollo 11, prepare for orbit insertion. Burn in 30 seconds. The burn started. Engines fired. Columbia slowed gradually. Orbit achieved. Step by step. Minute by minute.
Slow, quiet, careful.
Lunar module separation. Next, the lunar module had to prepare for landing. Eagle, separated from Columbia. Astronauts checked connections, communications, and systems. Thrusters fired slowly to control descent. Flight path adjusted carefully. Every calculation monitored from Earth. Every minor correction broadcast with deliberate slowness. Houston, Eagle, systems check complete.
Preparing descent. Eagle floated in space. delicate and vulnerable. Every movement measured, every motion planned, every moment tense, yet unhurried. Descent to the moon. The descent began. Eagle's engines fired slowly. Velocity decreased gradually. Altitude measured constantly. Astronauts monitored terrain below. Gray craters, rocks, shadows. Distance calculated down to meters. Communications were slow, sometimes delayed. Each confirmation repeated. Roger, Eagle. Adjust 0.5 meters port. Copy, Houston. The slow rhythm of conversation matched the slow rhythm of descent. Every second mattered. Every second stretched into eternity. Preparing for landing. The final approach was terrifying in its quiet. Altitude 500 meters, 400, 300, 200. Manual adjustments required delicate touch. Engines throttled carefully. Velocity controlled to prevent crash or bounce. Every movement deliberate. Astronauts spoke in calm tones, though internally, adrenaline surged. This was the culmination of years of training, simulation, and patience. Step by slow step. Bolt by bolt. Heartbeat by heartbeat. Eagle's landing gear touched the lunar surface slowly. Not with a crash, not with fanfare, but with quiet precision. Dust floated upward in microgravity. Shadows stretched across the gray plains. Houston, Tranquility Base here. The Eagle has landed. A simple sentence, slow and calm, carrying years of training, fear, and anticipation. Mission Control paused, almost holding its collective breath. Each engineer, each technician, each person in that room knew the magnitude of the moment. Yet everything remained deliberate. Nothing rushed. Preparations to exit. Astronauts prepared to step outside. Suits checked, helmets sealed, gloves tightened. Eagle were ready for EVA. Buzz Aldrin monitored systems while Neil Armstrong slowly moved toward the hatch. Every motion careful. Every step deliberate. Even breathing measured. Astronauts floated to the door. The hatch opened with a soft hiss. The ladder descended, each rung inspected, touched, and rechecked. Armstrong's first step. Neil Armstrong paused at the final rung. The moon beneath him silent, immense, alien. Deep breath. I'm stepping off now. And slowly, deliberately, his boot touched the lunar surface. One small step. Slow, careful. Weight distributed evenly. Dust puffed beneath his foot. He tested the terrain. Balance maintained. Every movement precise. Yet human. Imperfect. Hesitant. The world held its breath, but the moment was intimate. Private in its quiet majesty. Buzz Aldrin joins. Buzz followed slowly. The hatch closed behind him. Gravity weak but present. Each step required adjustment. Movement was deliberate, slow, careful. He paused, testing each step. Glancing at Armstrong. Glancing at Earth. A distant blue dot. They spoke softly to each other and to Houston. The surface is fine. Dust is soft, but firm underneath. Proceed slowly. Each word measured. Each sentence deliberate. Even radio delays added to the rhythm. Collecting samples. The astronauts moved across the surface slowly, bending carefully to collect rocks. Placing samples into bags with meticulous care. Testing soil mechanics. Recording observations. This rock is slightly jagged. Appears igneous. Placing in bag 3. Every motion slow. Every pause purposeful. Even the act of standing up required deliberate thought, given the low gravity. Step by step, bag by bag, observation by observation. The world below imagined grandeur. NASA knew patience, repetition, and detail were survival. Planting the flag. The American flag had been rehearsed many times. Astronauts carried it to a chosen spot. The base extended. Poles slowly inserted. Armstrong and Aldrin adjusted it carefully. It was not just symbolism. It was human ingenuity meeting alien terrain. Houston, flag planted. A quiet triumph. No fanfare, no dramatics. Just deliberate action, slow and careful. Experiments and documentation. Apollo 11 carried a suite of experiments.
seismometers to record moonquakes, retroreflectors for laser measurements, solar wind detectors. Each experiment carefully measured angles, adjusted orientations, documented every step. Cameras were mounted slowly, photographs taken methodically, notes recorded with painstaking care. Every detail mattered. Even seemingly trivial mistakes could jeopardize data collection. Returning to Eagle. After hours on the surface, the astronauts prepared to return. Modules checked, samples secured, life support verified. Step by slow step, they climbed the ladder. Each movement deliberate. The moon's gravity made motions different, slower, more calculated. Eagle were back inside. The hatch sealed. Systems checked. The lunar module prepared for ascent. Everything was slow. Everything deliberate. Because haste could destroy months of preparation, years of effort, and countless lives. Radio communications and delays. Every communication with Earth carried delays. Houston, we're beginning ascent now. Mission Control waited for each word to travel across the void. Seconds passed. Silence filled the room, tension thick, but calm maintained. Ascending nominally. Even the simplest phrases felt monumental. Every exchange deliberate, slow, and measured. Lunar module ascent. Eagle's ascent stage engines fired. Slow increase in velocity. Trajectory adjusted carefully to rendezvous with Columbia. Astronauts monitored instruments. Communicated every minor correction. Houston, trajectory looks nominal. Roger, maintain current ascent rate. Minutes stretched. Seconds mattered. Step by step, the lunar module moved toward the command module. Docking approached with slow, methodical precision. Every micro-adjustment required concentration, patience, and human judgment.
Rendezvous and return. Finally, Columbia and Eagle docked.
Astronauts transferred lunar samples carefully. Checked systems again. Prepared for trans-Earth injection. The moon behind them, silent and still. Earth ahead, slowly growing in. Size. The journey back began deliberately. Every stage monitored. Every system rechecked. Every motion deliberate. Step by step. Bolt by bolt. Heartbeat by heartbeat. Apollo 11 had returned to Earth. The world had cheered, celebrated, and moved on. But NASA continued. Slowly. Quietly. The moon was no longer a distant dream. It had been touched, explored, sampled, and yet human space exploration was just beginning. Apollo 12 followed, meticulous in planning, launches and landings executed step by step, every procedure slower than it appeared, every system double-checked, every astronaut movement deliberate. The lunar surface was revisited, samples collected, photographed, analyzed. Even the simplest rock required careful handling. Later Apollo missions, Apollo 13 demonstrated the unforgiving nature of space. A faulty oxygen tank caused a slow, terrifying chain of failures. Astronauts and engineers worked together, step by slow step, to survive. Each problem analyzed, each solution implemented deliberately. Every adjustment could mean life or death. Apollo 14, 15, 16, and 17 followed. Each mission slightly more ambitious. Increased. Lunar rovers introduced. Astronauts traversed the surface with deliberate, careful movements. Every detail documented. Every action measured. Space was not glamorous. It was patient. It was meticulous. It required slow attention to detail. Research and knowledge. The Apollo program left humanity with treasures of knowledge. Lunar rocks studied for decades. Soil mechanics and composition analyzed slowly, repeatedly. Seismometers left behind continued to report data long after the astronauts returned. Every discovery was incremental. Each paper written carefully, slowly, citing observations and measurements. No single revelation changed everything overnight. Progress was cumulative, measured, deliberate. Human. The end of Apollo. By the early 1970s, Apollo faced challenges. Budgets were tight. Political support waned. Public attention shifted elsewhere. NASA could not continue lunar missions indefinitely.
Each flight cost billions. Risk remained ever present. Human attention, mechanical limits, and funding constraints converged. And so the Apollo program gradually ended. Not abruptly, but quietly. Step by slow step, missions concluded. Satellites continued to orbit. Human presence on the moon paused. Even as Apollo ended, its impact remained profound. Technologies developed slowly migrated into civilian life. Materials engineered for space improved airplanes, electronics, and computing. Guidance systems and telemetry shaped industries far beyond NASA's walls, and people remembered stories of astronauts' careful, deliberate steps on the moon. Moon inspired generations. Children imagined space. Engineers dreamed bigger. Step by slow step, humanity's reach had expanded. NASA's shift. With the moon behind them, NASA quietly shifted priorities. Focus moved from rapid exploration to sustainable development. Space Shuttle program conceived. Reusable spacecraft promised slower, more cost-effective access to low Earth orbit. Plans carefully plotted over years, not months. Engineers and astronauts adapted. Procedures learned on Apollo applied, refined, and perfected. Lessons from failures, near misses, and successes were studied, archived, and codified. Every detail mattered. Every slow improvement shaped the future. Space Shuttle beginnings. The shuttle was not born overnight. Designs evolved over years. Materials tested for durability. Engines simulated exhaustively. Crew modules carefully designed for reuse and safety. Astronauts trained extensively. Ran endlessly. Each landing rehearsed repeatedly. Failures from Apollo, Gemini, and Mercury analyzed to prevent repetition. The first shuttle launch was slow in planning, deliberate in execution. Everything measured, every step carefully monitored. The program emphasized safety, repeatability, and patience over spectacle. Quiet achievements. Shuttle missions quietly changed how humans access space. Satellites deployed. Space labs maintained. Experiments performed slowly, meticulously, methodically. Progress was incremental. Scientific results built upon careful observation. Nothing flashy, nothing instantaneous. Yet each contribution was permanent, cumulative, and deliberate. NASA had evolved. From Apollo's daring leaps to shuttle's careful steps, the rhythm of exploration had slowed, but continued. Humans in space, slowly expanding. Astronauts to experience space. Longer missions. Laboratory experiments. Repair and maintenance in orbit. Astronauts moved deliberately. Procedures learned on Apollo applied. Every handhold, every step in microgravity carefully planned. Patience became the defining trait. Space was not glamorous. Space was precise. Step by step. Bolt by bolt. Heartbeat by heartbeat. Scientific legacy. NASA's slow, deliberate exploration yielded decades of data. Moon rocks, orbital satellites, shuttle experiments, all accumulated knowledge. Scientific papers carefully written, analyzed, peer-reviewed. Technologies applied in medicine, electronics, transportation. Every slow, deliberate step in space had echoes on Earth. Incremental progress created a foundation for future explorers. The Space Shuttle program finally launched into reality. It was not a leap like Apollo. It was a slow, deliberate evolution. Every shuttle designed carefully, engines tested exhaustively, tiles for heat protection meticulously applied and checked. Crew compartments designed for repeated use, life support systems optimized. Astronauts trained patiently. Simulators ran endlessly. Procedures rehearsed over and over. Landing approaches practiced at slow, deliberate increments. Measured speed. NASA had learned, speed and spectacle could not replace caution. Every mission was planned, step by step. Every task documented. Every failure analyzed and learned from. Shuttle missions begin. Early shuttle flights focused on simple objectives. Deploying satellites. Testing reusable systems. Monitoring Earth's environment. Astronauts moved slowly, deliberately in microgravity. Every handhold, every maneuver, every switch flip was precise. The world watched with awe, but the quiet patience of engineers and astronauts
remained largely invisible. Progress was incremental, cumulative, and careful. Each shuttle flight added knowledge. Each experiment expanded humanity's understanding of space. Research and experiments. Shuttle missions carried laboratories. Protein crystals grown in microgravity. Materials tested for durability in space. Earth observations. Carefully measured. Experiments executed slowly, deliberately. Data recorded, analyzed, cross-checked. Nothing flashy, nothing instantaneous, but permanent. Useful. Step by step, humanity learned how to live and work in orbit. Apollo had been daring, shuttle was precise. NASA's quiet shift. Beyond shuttle missions, NASA began shifting priorities. Focus moved toward long-term sustainability, space science, Earth observation, international cooperation, planning for space stations, reusable rockets, and interplanetary probes. Budgets still constrained, political pressure still present. NASA learned patience. Slow, measured progress became their mantra. No longer just firsts or giant leaps. Instead, careful construction, cumulative knowledge, human persistence, long-term impact on space exploration. The effects of Apollo and shuttle rippled outward. Satellite networks improved communication and weather monitoring. Earth science benefited from orbital observation. Technology developed for spacecraft integrated into everyday life. Computers and guidance systems. Material science innovations. Environmental monitoring tools. Step by slow step, NASA had shaped a new human relationship with space. Humans in space, slowly expanding. Shuttle missions allowed humans to stay longer in space. Days turned into weeks in orbit. Experiments required deliberate, repeated attention. Crew adapted to life in microgravity. Astronauts moved deliberately. Every motion slow, controlled, methodical. Human patience became as important as technological sophistication. Even small movements mattered. A misplaced tool could cause hours of work. A poorly secured experiment could fail. And yet each day, humans learned to exist in space, methodically. International and scientific collaboration. NASA's slow, deliberate approach extended to global partnerships. Europe, Japan, and Russia collaborated on experiments and missions. Space stations became platforms for long-term research. Knowledge accumulated slowly, carefully, collaboratively. Each mission planned, discussed, and executed with patience. Every detail mattered. Every misstep could cost lives, time, or money. The moon landing had been a triumph. Shuttle and subsequent programs ensured that triumph evolved into sustained achievement. Legacy of Apollo and shuttle. Looking back decades later, Apollo had demonstrated human courage and ingenuity. Shuttle had perfected precision, patience, and sustainability. The combination shaped humanity's understanding of space. No longer just can we reach it, instead, how do we live, work, and thrive in it? Bolt by bolt, heartbeat by heartbeat, NASA had transitioned from spectacle to responsibility. Every slow, meticulous effort laid the foundation for the International Space Station, robotic probes to Mars, and the Artemis program to return humans to the moon. Reflection, the slow impact. The impact of these decades is quiet but profound. Technological advancement often unseen. Scientific data slowly changing how we understand our planet. Humanity trained to operate in an alien environment, step by careful step. The story of NASA after the moon is not about sudden leaps. It is about patient accumulation of knowledge, deliberate planning, and careful exploration. The world watched the moon landing and cheered. But the quiet work afterward, the incremental, deliberate, slow steps, ensured that space exploration could continue safely and sustainably. Closing thoughts. NASA's journey after the moon teaches patience. Is rarely instant. Great achievements come from small, careful, repeated actions. From Apollo to shuttle, from Tranquility Base to low Earth orbit, humans learn to move deliberately. To measure, observe, check, and adjust. And in that slow, quiet way, humanity changed forever. Step by step, bolt by bolt, heartbeat by heartbeat. The moon was only the beginning, and the journey continues. Still deliberate, still patient, still human.